Pluto, once considered the ninth and most distant planet from the Sun, is now the largest known dwarf planet in the Solar System. It is also one of the largest known members of the Kuiper Belt, a shadowy zone beyond the orbit of Neptune thought to be populated by hundreds of thousands of rocky, icy bodies each larger than 62 miles 100 kilometers across, along with 1 trillion or more comets. In 2006, Pluto was reclassified as a dwarf planet, a change widely thought of as a demotion. The question of Pluto's planet status has attracted controversy and stirred debate in the scientific community, and among the general public, since then. In 2017, a science group including members of the New Horizons mission proposed a new definition of planethood based on round objects in space smaller than stars, which would make the number of planets in our solar system expand from 8 to roughly 100. American astronomer Percival Lowell first caught hints of Pluto's existence in 1905 from odd deviations he observed in the orbits of Neptune and Uranus, suggesting that another world's gravity was tugging at these two planets from beyond. Lowell predicted the mystery planet's location in 1915, but died without finding it. Pluto was finally discovered in 1930 by Clyde Tombaugh at the Lowell Observatory, based on predictions by Lowell and other astronomers. Pluto got its name from 11-year-old Venetia Burney of Oxford, England, who suggested to her grandfather that the New World get its name from the Roman god of the underworld. Her grandfather then passed the name on to Lowell Observatory. The name also honors Percival Lowell, whose initials are the first two letters of Pluto. Since Pluto is so far from Earth, little was known about the dwarf planet's size or surface conditions until 2015, when NASA's New Horizons space probe made a close flyby of Pluto. New Horizons showed that Pluto has a diameter of 1,473 miles 2,370 kilometers, less than one-fifth the diameter of Earth, and only about two-thirds as wide as Earth's moon. Observations of Pluto's surface by the New Horizons spacecraft revealed a variety of surface features, including mountains that reach as high as 11,000 feet 3,500 meters, comparable to the Rocky Mountains on Earth. While methane and nitrogen ice cover much of the surface of Pluto, these materials are not strong enough to support such enormous peaks, so scientists suspect that the mountains are formed on a bedrock of water ice. Photos of Pluto and its moons. Pluto's surface is also covered in an abundance of methane ice, but New Horizons scientists have observed significant differences in the way the ice reflects light across the dwarf planet's surface. The dwarf planet also possesses ice-ridged terrain that appears to look like a snakeskin. Astronomers spotted similar features to Earth's penitence, or erosion-formed features on mountainous terrain. The Pluto features are much larger. They are estimated at 1,650 feet 500 meters tall, while the Earth features are only a few meters in size. Another distinct feature on Pluto's surface is a large heart-shaped region known unofficially as Tombaugh Regio after Clyde Tombaugh. Regio is Latin for region. The left side of the region, an area that takes on the shape of an ice cream cone, is covered in carbon monoxide ice. Other variations in the composition of surface materials have been identified within the heart of Pluto. In the center left of Tombaugh Regio is a very smooth region unofficially known by the New Horizons team as Sputnik Planum, after Earth's first artificial satellite, Sputnik. This region of Pluto's surface lacks craters caused by meteorite impacts, suggesting that the area is, on a geologic timescale, very young, no more than 100 million years old. It's possible that this region is still being shaped and changed by geologic processes. These icy plains also display dark streaks that are a few miles long, and aligned in the same direction. It's possible the lines are created by harsh winds blowing across the dwarf planet's surface. NASA's Hubble Space Telescope has also revealed evidence that Pluto's crust could contain complex organic molecules. Pluto's surface is one of the coldest places in the Solar System, at roughly -375 degrees Fahrenheit (-225 degrees Celsius). When compared with past images, pictures of Pluto taken by the Hubble Space Telescope revealed that the dwarf planet had apparently grown redder over time, apparently due to seasonal changes. Pluto may have had a subsurface ocean, although the evidence is still out on that finding. If the subsurface ocean existed, it could have greatly affected Pluto's history. For example, scientists found that the zone of Sputnik Planitia redirected Pluto's orientation due to the amount of ice in the area, which was so heavy it affected Pluto overall. New Horizons estimated the ice is roughly 6 miles 10 kilometers thick. A subsurface ocean is the best explanation for the evidence, the researchers added, although looking at less likely scenarios, a thicker ice layer or movements in the rock may be responsible for the movement. If Pluto did have a liquid ocean, and enough energy, some scientists think Pluto could harbor life. Pluto's highly elliptical orbit can take it more than 49 times as far out from the Sun as Earth. Since the dwarf planet's orbit is so eccentric, or far from circular, Pluto's distance from the Sun can vary considerably. The dwarf planet actually gets closer to the Sun than Neptune is for 20 years out of Pluto's 248 Earth-years-long orbit, providing astronomers a rare chance to study this small, cold, distant world. As a result of that orbit, after 20 years as the eighth planet in order going out from the Sun, in 1999, Pluto crossed Neptune's orbit to become the farthest planet from the Sun until it was demoted to the status of dwarf planet. When Pluto is closer to the Sun, its surface ice is thaw and temporarily form a thin atmosphere, consisting mostly of nitrogen, with some methane. Pluto's low gravity, which is a little more than 1/20th that of Earth's, causes this atmosphere to extend much higher in altitude than Earth's. When traveling farther away from the Sun, most of Pluto's atmosphere is thought to freeze and all but disappear. Still, in the time that it does have an atmosphere, Pluto can apparently experience strong winds. The atmosphere also has brightness variations that could be explained by gravity waves, or air flowing over mountains. While Pluto's atmosphere is too thin to allow liquids to flow today, they may have streamed along the surface in the ancient past. New Horizons imaged a frozen lake in Tombaugh Regio that appeared to have ancient channels nearby. At some point in the ancient past, the planet could have had an atmosphere roughly 40 times thicker than on Mars. In 2016, scientists announced that they might have spotted clouds in Pluto's atmosphere using New Horizons data. Investigators saw 7 bright features that are near the terminator, the boundary between daylight and darkness, which is commonly where clouds form. The features are all low in altitude and roughly about the same size, indicating that these are separate features. The composition of these clouds, if they are indeed clouds, would likely be acetylene, ethane and hydrogen cyanide. A close-up view of the surface of Pluto, taken by the New Horizons space probe in July 2015, revealed the presence of icy mountains on the dwarf planet's surface. Credit NASA Dwarf some of Pluto's parameters, according to NASA: atmospheric composition, methane, nitrogen. Observations by New Horizons show that Pluto's atmosphere extends as far as 1,000 miles 1,600 kilometers above the surface of the dwarf planet. Magnetic field: it remains unknown whether Pluto has a magnetic field, but the dwarf planet's small size and slow rotation suggest it has little to no such field. Chemical composition: Pluto probably consists of a mixture of 70% rock and 30% water ice. Internal structure: the dwarf planet probably has a rocky core surrounded by a mantle of water ice, with more exotic ices such as methane, carbon monoxide and nitrogen ice coating the surface. Pluto's rotation is retrograde compared to the Solar System's other worlds. It spins backward, from east to west. Average distance from the Sun: 3,670,050,000 miles, 5,906,380,000 kilometers, 39.482 times that of Earth. Perihelion: closest approach to the Sun: 2,756,902,000 miles, 4,436,820,000 kilometers, 30.171 times that of Earth. Aphelion: farthest distance from the Sun: 4,583,190,000 miles, 7,375,930,000 kilometers, 48.481 times that of Earth. Pluto has 5 moons: Charon, Styx, Nix, Kerberos and Hydra, with Charon being the closest to Pluto and Hydra the most distant. In 1978, astronomers discovered that Pluto had a very large moon, nearly half the dwarf planet's own size. This moon was dubbed Charon, after the mythological demon who ferried souls to the underworld in Greek mythology. Because Charon and Pluto are so similar in size, their orbit is unlike that of most planets and their moons. Both Pluto and Charon orbit a point in space that lies between them, similar to the orbits of binary star systems. For this reason, scientists refer to Pluto and Charon as a double dwarf planet, a binary system. Pluto and Charon are just 12,200 miles 19,640 kilometers apart, less than the distance by flight between London and Sydney. Charon's orbit around Pluto takes 6.4 Earth days, and 1 Pluto rotation, a Pluto day, also takes 6.4 Earth days. This is because Charon hovers over the same spot on Pluto's surface, and the same side of Charon always faces Pluto, a phenomenon known as tidal locking. While Pluto has a reddish tint, Charon appears more grayish. In its early days, the Moon may have contained a subsurface ocean, though the satellite probably can't support one today. Compared with most of the Solar System's planets and moons, the Pluto-Charon system is tipped on its side in relation to the Sun. Observations of Charon by New Horizons have revealed the presence of canyons on the Moon's surface. The deepest of those canyons plunges downward for 6 miles (9.7 kilometers). A long swatch of cliffs and troughs stretches for 600 miles (970 kilometers) across the middle of the satellite. A section of the Moon's surface near one pole is covered in a much darker material than the rest of the planet. Similar to regions of Pluto, much of Charon's surface is free of craters, suggesting the surface is quite young and geologically active. Scientists saw evidence of landslides on its surface, the first time such features have been spotted in the Kuiper Belt. The Moon may have also possessed its own version of plate tectonics, which caused geologic change on Earth. In 2005, scientists photographed Pluto with the Hubble Space Telescope in preparation for the New Horizons mission and discovered 2 other tiny moons of Pluto, now dubbed Nix and Hydra. These satellites are 2 and 3 times farther away from Pluto than is Charon. Based on measurements by New Horizons, Nix is estimated to be 26 miles 42 kilometers long and 22 miles 36 kilometers wide, while Hydra is estimated at 34 miles 55 kilometers long and 25 miles 40 kilometers wide. It is likely that Hydra's surface is coated primarily in water ice. Scientists using Hubble discovered a 4th moon, Kerberos, in 2011. This moon is estimated to be 8 to 21 miles 13 to 34 kilometers in diameter. On July 11, 2012, a 5th moon, Styx, was discovered with an estimated width of 6 miles or 10 kilometers, further fueling the debate about Pluto's status as a planet. The 4 newly spotted moons may have formed from the collision that created Charon. Their orbits have been found to be highly chaotic. NASA's New Horizons mission is the first probe to study Pluto, its moons and other worlds within the Kuiper Belt up close. It was launched on January 2006, and successfully made its closest approach to Pluto on July 14, 2015. The last of the data was downloaded to Earth in 2016. New Horizons is now on its way to the Kuiper Belt object 2014 MU69, which it will fly by on January 1, 2019. The New Horizons probe carries some of the ashes of Pluto's discoverer, Clyde Tombaugh. The limited knowledge of the Pluto system created unprecedented dangers for the New Horizons probe. Prior to the mission's launch, scientists knew of the existence of only 3 moons around Pluto. The discovery of Kerberos and Styx during the spacecraft's journey fueled the idea that more satellites could orbit the dwarf planet, unseen from Earth. Collisions with unseen moons, or even small bits of debris, could have seriously damaged the spacecraft. But the New Horizons design team equipped the space probe with tools to protect it during its journey. The leading hypothesis for the formation of Pluto and Charon is that a nascent Pluto was struck with a glancing blow by another Pluto-sized object. Most of the combined matter became Pluto, while the rest spun off to become Charon, the idea suggests. Infographic Pluto, a dwarf planet oddity. Additional reporting by staff writer Calla Cofield and by Elizabeth Howlam. Nola Taylor read, Space.com contributors.